All right, this is the opening section to the unit on sequences and series for Algebra 2. And this first section is going to be just an introduction to sequences. So what is a sequence? A sequence is simply a list of numbers separated by a comma. And then a series is going to be taking that sequence and adding the terms together. So, for example, if we have the numbers 2, 4, 6, 8, and 10, that would be considered a sequence. And if we add those numbers together, 2 plus 4 plus 6 plus 8 plus 10, then that becomes a series. All right, so that's just simply the difference between a sequence and a series. And your list of numbers, they will have some sort of expression or equation that can be used to generate this list. Some notation: a sub n is going to be the value of the nth term of your sequence. So for example, a sub 1 would be the first term. A sub 2 would be the second term, and so on. So the n value that you see right here, that just indicates what the term number is going to be. A sub 1 would be your first term, a sub 2 second term, a sub 3 third term, and what I'm saying in between is sub, sub, which means subscript. All right, so make sure that you write this as a subscript on your numbers here. And so then we have another notation, which is going to be a sub n minus 1. So a subscript n minus 1. Now that is going to just simply represent the value of the previous term. So for example, if you have a sub n is a sub 7, that means that your n value is 7. Well, a sub n minus 1 then would be a subscript 7 minus 1, which would be a sub 6. And if you think about your order of things, a sub 7 would be the seventh term in a sequence of numbers, and a sub 6 would be the term right before that in your sequence of numbers. Because a sequence of numbers would be written as a sub 1, comma, a sub 2, a sub 3, a sub 4, and so on. Okay? All right, so then we have a couple of different types of equations that we're going to be using. The first is going to be an explicit equation, and then the other is a recursive equation. So what's the difference between these two things? In an explicit equation, the value of each term in the equation is dependent on, or each term in the sequence rather, is dependent on n. And then in a recursive equation, the value of each term in the sequence is dependent on a sub n. Let me just change this. This is sequence. Okay. All right, so let's take a look at a few problems and see how this works out with our vocabulary. So a sequence is defined explicitly as a sub n equals negative 3n plus 4. Find the first 5 terms of the sequence. All right, so we need to find a sub 1, which would be your first term, and that just simply means that your n value is 1, and when we substitute that in, you end up with negative 3 times 1 plus 4 which is 1. All right, now finding a sub 2 would be negative 3, and your n value this time is 2. Negative 6 plus 4 is negative 2. Then we got to find the third term, so that's going to be negative 3 times 3, which is negative 5. The fourth term is negative 3 times 4, which is negative 8. And then the fifth term is negative 3 times 5 plus 4, which is negative 11. All right, so writing this out as a sequence, your first term is 1, then negative 2, then negative 5, then negative 8, and negative 11. So this right here is an explicit equation, all right, because this equation, the value of each term is dependent upon the number of the term in that sequence, which is kind of nice because if I want to find the 30th term in this sequence, I do not have to find all of the terms leading up to the 30th term. All I need to do is plug in 30 right here, and I can find out that the 30th term has a value of negative 86. And so the explicit equation is really nice for that. So the next problem says a sequence is defined recursively this time as a sub n equals 2 times a sub n minus 1 minus 3, where a sub 1 is equal to 4, and it says find the first 5 terms. All right, well, finding the first 5 terms, the first term was already given to us, and that is 4. The second term means that your n value is going to be 2. So we've got second term, so everywhere you see an n, you replace it with 2. All right, so this is going to be a times, or 2 times a subscript 2 minus 1 minus 3, which means we're finding 2 times a sub 1. And now remember that a sub 1 had a value of 4. So 2 times 4 is 8, minus 3 is going to give us 5. All right, so now we're going to find the third term, which is 2 times a sub 3 minus 1 minus 3, which is 2 times a sub 2, and a sub 2 had a value of 5. So 2 times 5 is 10, minus 3 will give us 7. All right, then we have the fourth term. Now remember that a sub n minus 1 is your previous term. So when we were finding the second term, this became the previous term, which was a sub 1. Finding the third term, this was the previous term, which was a sub 2. So for finding the fourth term, this will be a sub 3. And a sub 3 had a value of 7. All right, so we could write this out, skipping one step here. This would be 2 times a sub 3 minus 3. And a sub 3 was 7, so 2 times 7 is 14, minus 3 gives us 11. And the fifth term will be 2 times the previous term of 11 minus 3, which is 22 minus 3 is 19. So our sequence of numbers here would be 4, 5, 7, 11, and 19. Now, one of the things with the sequences that are defined recursively is that if I want to know what is the 52nd term in this sequence, I cannot just put 52 into my equation. This equation, the value of the 52nd term, means that I would have to find out what the 51st term is. And in order to find the 51st term, I have to know the 50th term. So in other words, if I want to find the value of the 52nd term, I have to find the value of all the terms leading up to that 52nd term. That's a drawback of defining a sequence recursively. All right, so on the next problem, it says to write an explicit and a recursive equation that describes the sequence. So explicitly, we're going to start these equations off with a sub n equals, because what that does is it says the value of each term is defined by this equation that follows this. All right, so explicit equation is going to be dependent upon n, which is your term number, which means when n is 1, we have to get a 2 out of this equation. When n is 2 for the second term, we have to get a 5. When n is 3, we have to get an 8. When n is 4, we have to get 11. And when n is 5, we have to get 15. The equation that will generate that will be 3n minus 1. So for your first term, meaning a sub 1, that would give you 3 times 1 minus 1, which is 2. For your second term would be a sub 2, which is 3 times 2 is 6, minus 1 is 5. Third term, 3 times 3 minus 1 is 8, and so on. All right, so then recursively, we want to think, what are we doing to the previous number to get the next number in this sequence? So if you look at the jump from 2 to 5, from 5 to 8, from 8 to 11, and 11 to 14, what we are doing is adding 3 each time to get the next number in the sequence. And so what we are doing then is saying we are taking the previous term, which means a sub n minus 1, and we are adding 3 to that every time. And with a recursive equation, you've always got a starting point. So our starting point is going to be a sub 1 has to start out at 2. All right, so the next question, write an explicit equation that describes this sequence. All right, so writing an explicit equation, so we're going to have a sub n equals. Now the numerator, if you'll notice, there is only a 4 in there, so what we're going to do is we are going to treat the numerators and the denominators separately. So the numerator always has a 4, so we can just put a 4 in that numerator. I'm going to ignore the negative signs for a minute and just concentrate on the numbers. All right, so if you look at the numbers 2, 5, 10, 17, and 26, we got to figure out how are we generating this sequence of numbers. So if you look at the first difference between the numbers, the first difference is 3, 5, 7, and 9. But the difference between those numbers is a consistent 2. When your second difference is the same, that indicates that this is a quadratic equation here. And so since it is quadratic, we're going to have an n squared. And the equation that will generate, or the expression that will generate this sequence of numbers is going to be n squared plus 1, where your first term, n is 1, 1 squared plus 1 is 2. For your second term, n is 2, 2 squared is 4, plus 1 is 5. For your third term, n is 3, and 3 squared plus 1 is 10, and so on. So the next thing we want to look at is our signs, because we see that the sign alternates. We have a negative, then a positive, then a negative, positive, negative, and so on. And the way we can create alternating signs is to take our numbers and multiply them by -1 raised to some power. Now in this case, the exponent is going to be n, because on your first term, when you have a sub 1, you'll have -1 raised to the first power, which is a -1. That just means -1 times this number, which will give us a negative. Now on your second term, your n value is 2, which means you're going to have -1 raised to the second power, which is a positive number. And that means our second term is positive. Third term, n is 3, exponent is 3, which creates a negative number. So your third term is a negative number. Fourth term, you have an even exponent, which is positive, and so on. All right. So next, how could you modify this equation to generate this sequence? All right. So again, we'll start it out. A sub n equals 4 over n squared plus 1, because it's the same sequence. The only difference is that instead of your first term being negative, your first term is positive, and then negative, positive, negative. So it alternates again, but it starts out with a positive. So we are still going to be multiplying by -1, but instead of just n for the exponent, we're going to use n plus 1. And the reason being is because our first term, a sub 1, you put 1 in for the n, which means your exponent is now a 2, and -1 squared is a positive number. So that means our first term is a positive number. The second term is a negative. So if we put a 2 in for the n for the second term, put a 2 in right here, gives us an exponent of 3. -1 to the third power is a -1, which means our second term is going to be a negative. For the third term, 3 plus 1, that's 4. It's an even number. So -1 to an even number is going to be positive. Third term, this will be, and so on. I'm sorry, fourth term, this will be 4 plus 1, which is 5, so it's going to be a negative value here. All right, so anytime you have alternating signs, this is what you are going to be looking at for trying to create that situation.